This is the Work Order Management System by Takunda and Brandon Loosbrock. Welcome to the management system for campus work orders. This system serves as a centralized database to efficiently manage and monitor campus work requests. It allows you to track work orders in real time, identify who's assigned to each task, and know who created the order. Additionally, you can determine the location or status of every order at any given moment. This system ensures clear communication, streamlined operations, and accountability across campus facilities. With this tool, managing campus tasks has never been easier. Let's talk about the benefits of the management system database. First, it ensures that work orders don't get lost, keeping everything organized and traceable. You can easily identify who's responsible for each task, promoting accountability. The system also makes information accessible so you can quickly find updates and details about an issue. Finally, it's quicker, more automated solution, reducing manual effort and saving valuable time. With these benefits, the database improves efficiency and ensures smoother operations across the campus. To implement the management system, we follow a clear setup plan. First, we input technician information, ensuring all relevant personnel are recorded in the database. Next, we include building information, which helps track locations for work orders. We also gather user information to identify who is creating and overseeing requests. Finally, we focus on managing orders, assigning tasks, monitoring progress, and ensuring everything is streamlined. This setup ensures the system is organized, efficient, and ready to handle campus work orders seamlessly. The management system ensures work orders are handled efficiently and effectively. First, work orders don't get lost in the system, meaning every request is accounted for, reducing errors or delays. Technicians also benefit from having more information to prepare. Details like location, required tools, and task specifics are readily available, allowing them to complete orders faster and more accurately. The system is automated, which means tracking work orders requires less manual input, saving time and effort for staff. Finally, you can easily track the status of orders, whether pending, in progress, or completed, ensuring full visibility and better workflow management. Altogether, this system makes managing work orders simpler and more reliable for everyone involved. This is the user interface for the current work order system. Although it isn't the most beautiful page, it serves its purpose. This is the basis for what this project is based on. The first page shown here prompts you to enter the building your order is for. The second page of the work order user interface tracks the name, phone number, email address, the room the work order is being submitted for, and a text box to provide the description of the task as well as the date it needs to be completed by. The last box would benefit from having a separate space to select when you need it by that only allows the user to input a date, but that is beyond the scope of the project. Let's go over the requirements matrix for our project, which provides a clear breakdown of the system requirements, responsible team members, and the progress so far. First, the table is divided into key sections. The ID, a unique number for each requirement. The module, the part of the system to which the requirement belongs, such as client, work order, assignment, technician, room, or building. A description, which is a brief explanation of the requirement. The source, all requirements were gathered by the internal analyst. The date, the target completion dates are either December 14th or December 15th, 2024. Group member, the responsible team member, which is either Takunda or Brandon in this situation. And the status, which indicates whether the requirement is complete or still pending. conceptual model for this database provides a visual representation of how all the entities in the set interact with each other. This paves the way to write business rules. These business rules are 1. A client makes one-to-many work orders. 2. A work order can be made by one and only one user. 3. A technician can be assigned to one-to-many work orders. 4. A work order can have one-to-many technicians assigned to it. 5. A work order can be placed on one and only one room. 6. A room can have one-to-many work orders placed on it. 7. A building can have one-to-many rooms. 8. A room can have one and only one building. The rest of this project will be presented by Mr. Takunda Midziwa.
Thank you there, Mr. Brandon. Thank you. Now let us talk about the logical model. This is where we get into how everything is actually structured, organized, and connected in the work order. So let's break it down. As you can see, we have entities such as clients, work order technicians, rooms, and buildings, and they are organized into tables. Each table has its own attributes, like the client's details or the work order status. The key aspect here is how these tables are connected. For example, each work order is linked to a specific client, and a work order can have one or more technicians working on it. We can also see that each work order is tied to a particular room, and rooms themselves are part of buildings. This logical model is the blueprint for the actual database. It helps us map out how everything will be stored and related in the system. By laying this out, we're ensuring that even when we move forward with creating the database, we have a solid plan in place. Talk about the SQL scripts. Let's start off with the drop statements. So these drop statements are used to ensure that if any of these tables already exist in the database, they get removed before we create new ones. So, for example, let's say we want to recreate assignment table, right? We first check if it already exists. If it does, we delete it with a drop table command in capital letters. We do the same for the work order, room, building, technician, and the client database. Tables. The purpose of these statements is to avoid errors during the setup process. If we don't clear out old versions of the tables, we might run into problems when trying to create or update them. This is basically just a cleanup step to make sure everything is fresh and ready for the next stage. Here we go. Next, we are creating the necessary tables in the database. So each one of these tables has a relationship with each other. For example, the work order table links to the client and room tables, and the assignment table connects technicians with the work orders that they are handling. And then the foreign key statements are there to make sure that the data remains consistent throughout these relationships. For example, like when we add a new work order, it can only reference existing clients. So time to add some data to our tables. Here, we're populating the database with some sample data to test its functionality. We added clients, buildings, and rooms. So for the buildings, it's a list of buildings on campus and the rooms within them. So this ensures that each room is linked to the correct building. And the work orders contains maintenance requests that have been submitted by students and faculty. So we also added some data for the technician tables. So this includes the people that are assigned to handle the work orders with their roles and contact information. And then the last step is where we added the data that links the technician to a work order. So in this slide, we'll show you how we created one of our select scripts or select statements. So this particular slide provides a list of work orders assigned to technicians. You will see that each row has a specific work order. The date, the date it was placed, its description, and its current status. So this makes it easier to track who is responsible for each task and provides important information for efficient management and follow-up. So this slide focuses on a summary of work orders that are categorized by room type and building. The query counts the number of work orders associated with each combination of building and room type, showing how many maintenance requests have been submitted for specific areas. As you can see here, the results are organized alphabetically by building name and then by room type for clarity and easy interpretation. So the select statement shows which technician has a pending task. So it lists each technician's name, role, and alongside the details of their pending work. So for each task, you'll see the work order ID, when the job was assigned, and a short description of the issue. As you can see here, the results are sorted by technician names and the dates, the work orders, and the dates when the work orders were created. Yeah. So this slide here highlights clients who have submitted more than one work order. Uh, it shows the client's ID, their name, contact information, and the total number of work orders they've made. The list is organized by the client's last and first name for easy referencing. What else? By identifying these frequent users, the system can help prioritize or address recurring issues more effectively. So for our last select statement, select script, in this slide, it presents work orders assigned to technicians with a specific date range. So it's going to be from December 8th, 2024 to December 9th, 2024. It includes the order ID, the date the work order was created, the technician assigned, a brief description of the work, and the dates when the assignment started and was completed. And the list is also is ordered first by the date of the work order and then by the technician's name. So this makes it easy to track assignments during the given time frame. Yeah. So for our conclusion, the management system streamlines the handling for work orders. It ensures efficiency and reliability. Um, Work orders are organized and tracked, and they prevent any from being lost, any records from being lost. And then technicians are better prepared with detailed information, improving task completion time and quality. And the other thing is automation reduces manual input, saving time, and it also minimizes errors. And the ability to track order status provides full visibility and accountability. And then overall, the system enhances communication, productivity, and overflow management across the campus. Then here's all our references formatted in APA.